Hey everyone, let's do another React 3 Fiber tutorial. And today's tutorial is going to be this scene right here. It is a spooky floating TV. Ooh, just floating in space. And even cooler, it is playing a video on it. Um, so how do we do that? Well, we're going to use video textures from Three.js, and we're going to learn how to do that in React 3 Fiber. And we're also going to cover um, the effects composer to make this scene a lot cooler. And that is providing this glitch effect and this wobbly, wibbly wobbly effect here. That is all coming from post processing effects. And we will learn how to do that too, also in React 3 Fiber. So let's get started. We're gonna start rebuilding the scene from scratch. But before we do that, I just want to show you real quick the assets that I needed in order to create this project. You won't need to do this part unless you want to make a slightly different type of scene. Maybe you want to make a movie theater instead of a TV floating. You could do that if you know how to model in Blender. So in Blender, I just threw together this blocky little CRT TV really quick, and then I exported it as a GLTF file. So anything you can model in Blender and export as a GLTF, you could use to follow along. Just be aware you'll want to know like what part of the model you're going to want the video to play on. So I broke this up into like the body of the TV and the screen. They're separated. And in fact, you'll see later, I'm not even going to use this screen face here. We're going to just create a new plane to use because it makes things a little easier. But yeah, so that's where I got the model from. And then also you'll need a video file to use as a texture. And for that, I am using this ghost town video that I shot a couple weeks ago out in the desert, just because it's, a little spooky, old, rundown, abandoned buildings and stuff. But your video could be whatever you want it to be, as long as you can play it in an HTML5 video tag, you can use the video, and you'll see why that is in a second. All right, so back to Code Sandbox and back to React 3 Fiber. It's time to start building up our project. So I'm going to just make a I'm going to make a Code Sandbox for you that you can start from, and it's going to look like this. And the only thing that's going to be different about this Code Sandbox is that I'm going to have like a starter, sort of like a wrapper for React 3 Fiber, just with all the imports you're going to need and some starting stuff we don't really need to cover in this video. And then I will also go ahead and have the assets that we talked about already uploaded into this project. So here's the TV GLTF. And then real quick before we start, let's also add the video file, and that'll be in the source directory. All right. So as soon as these two assets are done uploading, and they are now, we can go and get started by removing the whole scene from this thing right here. So I'm just going to delete all this stuff from the project because we don't need it. And then we can also delete these unused imports like the box and use ref. All of that, we don't need any of that. So this is enough to get started with. And we can begin fleshing this out. One of the first things that might be good to do would be to add the floor of the scene. Just to get that out of the way, there is a plane down here just kind of sitting on the ground so that light can fall on it and make things look a little more interesting. If I want to do that, so let's just make a new component and we'll call it ground. And then, in fact, let's just copy it from here. and call it the floor just to be consistent. So this floor component returns a mesh, and the mesh is rotated on its side. Math.pi divided by 2 is, negative math.pi divided by 2 is a radians value for an angle, and that will flip the plane down on its side. And then the mesh is created from some geometry and a material. So there is a geometry of plane buffer geometry, and it is 100 by 100 in size. And then we actually don't need this third argument, so let's just get rid of that. And the mesh standard material color white is fine. Leaving one more step, which is just to attach it to our scene by adding it to the canvas. And there we go. Now we have a floor. Let's make this a little more interesting by adding the orbit controls from Drei. Drei is a library of helpers for React 3 Fiber written by the same author. And it's super convenient to be able to just use that. Oh, here it is. So we need to import orbit controls first from Drei. So let's add that. We do need those other two imports, but we'll do them later. And then you can add the orbit controls anywhere inside the canvas and they'll just work. So once you add this component, now you can drag around on the screen and things will kind of rotate and move. The camera is moving essentially. We do want to lock down the angle of movement on the orbit controls so that you can't just go in any direction, because we don't want to be able to look under the floor. First off, by default, a plane only has one side visible. You can change that, but we don't really care, because if you were under the floor and it was visible, it would still block out everything interesting. So what we really want to do is have the orbit controls be limited so that you can't rotate them under the floor. And to do that, you just have to add these two props right here, max polar angle and min polar angle. Those will just set restrictions on how far you can rotate the camera. So if you put those in as props, now suddenly you're kind of locked down. You can't go higher than straight up, and you can't go lower than the floor. And again, this is in radians. So math.pi divided by 2 is kind of like straight on flat. Great. And one more thing that we could do just to set up the scene is add fog. Fog is also kind of built into Three.js. And so in React 3 Fiber, it's really easy to use. You just need to add a fog component under the canvas. And React 3 Fiber will figure out how to attach that to the scene. You do have to have this attach prop here. Essentially, it just sets the fog property on the scene in Three.js automatically. And the fog takes 3 arguments: a color, a starting point for the fog to begin, and then like a ending point where the fog becomes like 100% black. I can show you kind of how that works. If I change the color, you'll see our fog is red. You'll notice that it looks a lot better when it's the same color as the background. So you generally want to have the same background color as you do have fog, because then it'll make a nice fade out. And if I change this to be higher, it kind of pushes the fog back. If I change the second integer argument to be higher, it pushes like the endpoint of the fog gradient out. So you can always play with these depending on your scene. If you were to have a different object and you don't use the TV object, you might want to change these to make it look right for your scene. But this is what works for what we're going to do. So we'll leave it as is, and there we have it. This is kind of like a nice little void for us to start working with. And we're ready to grab our TV. So let's make another component. We'll call that TV. Oops. If I can type, and return null temporarily. Fix my arrow function. All right. So the TV, remember, is going to load some geometry from this file here, TV GLTF. This is the export from Blender. So we are going to need to use a loader. And there are a couple different ways to do geometry loading, but as it so happens, the Drei package, and let me just pull that up for you really quickly so that you can see the docs for it. You'll want to probably go here and reference it all the time. So this is the package, and inside of there, there's a bunch of helpers for using loaders. Here's the use GLTF loader, which is probably the most common one you'll use because GLTF is the preferred file format for exporting when we're talking about WebGL. So we're going to use this guy. And the way you use that is to first you have to import it. So let me add that here. And then it is a hook. So within the TV component, we need to say use GLTF and then pass that a string, which is a path to the file we're going to load. And just to show you what this does, let's console log the entire return value from that hook. This is pretty interesting. Probably need to refresh here. And yeah, we need to add our TV to the scene as well. And then one more thing is because we're doing an async loading operation to get the geometry, the way this hook works is it uses suspense. So we also need to wrap this in suspense with a fallback prop of some type. Null just means that it will render nothing until it's done loading. All right, and then suspense also needs to be imported from React. Now that that's finally done, our console log is working. And so all we're doing this for is to look at what the structure of a GLTF file is after it's been loaded. It has a bunch of stuff in it. So if our scene had cameras, they would be there. If our scene had animations and actions, they would be in here. There is a scene object that has all of the parts composed together. But what we want to work with is actually the nodes, because we're going to need to break down the imported geometry a little bit so that we can control it dynamically from within React 3 Fiber. By that, what I mean is there's like a screen already in the TV import, and we're actually going to replace the screen with some custom geometry. So really, the only thing we want to import is this TV mesh here. In fact, we're not even going to use the materials on the mesh, which we could do, but we're not. So we just want the TV. And so in order to do that, what we need to do is we can destructure first the nodes part of the GLTF right here on the import. And then next we can just recreate that. So let's start by copying over from the other project and get rid of this. So this is all that we need in order to do the TV part of this. And we have to get rid of that console log as well. All right, so here's what's happening. So if you remember, we were importing that whole object, and part of that was the nodes. And so the nodes had a key called TV, and the TV has some buffer geometry underneath it. So we're actually just going to grab that buffer geometry out of the GLTF import right here, and then we're going to create a new mesh using that geometry. And then we're going to set a new material on it, just a white mesh standard material. And that gets us our TV. We also have a group wrapping the mesh with some rotation on it, just to make it look a little more ominous, like the TV's just floating in the air. This kind of reminds me of the game Control, if any of you have played that. This crazy floating TV. And these numbers here for the rotation are just, I messed around with them. If you change them, you'll see what all the different values are doing. But I would just use these if you want, or play around and find some other cool ones. So that is enough to import the TV. So the next step that we need to do is we need to put the front of the TV back on. So we need to add the screen with the video file. So that's an interesting thing to do, because the way that the video texture works in Three.js depends on having a HTML5 node in the DOM for the video. And probably the best way to do that is just to use JavaScript to create that node in our component and then reference it. But you could actually technically, in your HTML, have a video that was completely outside of React. And as long as you can get a reference to it somehow, you can create a video texture from it. And that's what we're looking at here in the Three.js docs. To create the texture, they're just passing in an element reference. So we can replicate that with a little trick here, where we are going to just use the DOM API to create a new video element. And then we're going to set all the properties on the element. And then we're going to return that element into the TV's component state with the name video. And what that's going to allow us to do is just have a component with a video element in it that we can reference. So let's just copy this again. Put it right here at the top of our component. We are going to need a few more imports. So we need to get useState from React. And then this URL here. Probably the easiest way to do that is just to import that file in JavaScript. And great, now we have a video. So the video is ready to go, but it's not actually anywhere in our scene. So the next step is to add another mesh under the same group as the body of the TV. That way it'll inherit all the same rotation and everything. But this time we're going to, instead of importing geometry, we're just going to create some new geometry. So we'll take that mesh, put it in here. And we get an error that 3 is not defined. The reason for that is that there's a side prop on the mesh standard material, which makes this plane double-sided. And that is an enum that's coming from the Three project. So we need to also import Three. And we'll do it like this. Do import star as Three from Three. And there we go. It looks like the video is playing. You can zoom in a little bit so you can see it a little better. You'll notice it's kind of like letterbox because it's a wider format than the size of the TV, but that's cool. That's realistic. If your video is the same aspect ratio as the model, that wouldn't be the case. I just copy and pasted this from the project because I don't want to focus on all the little details, but you'll notice that this mesh has rotation and position, so I can move this plane around. If I were to change that to like -1, see now the screen is like way out in front of the TV. It's just its own object, so it just means you can control it independently. So I will inset it back into the TV by using this position here. If I were to change the rotation and stuff, same thing. Just normal plane geometry. But where the magic is really happening is just by inside the mesh standard material, which is just like this other one, but it has a video texture attached to the map and to the emissive map. And these are two different settings of the mesh standard material. If you go to the Three.js docs and look at mesh standard material, you'll see that there is an emissive map, there's an emissive color, and then there's just the map, the color map. The reason that we're doing both is because a TV screen, like it is emissive, right? It's backlit. There's lighting coming from the TV. And even though in Three.js, this isn't like casting light on other objects, it is better because if you don't set the emissive map, then it's going to treat the color like it was a flat object, which means it would have to have light cast on it to be bright. With the emissive map, the screen will just be bright automatically, even if there were no other lights in the scene. Like for example, if I delete this directional light, everything is black, but you can still see the screen because it is emissive. If I get rid of that emissive map, now suddenly there's no more video. Also, so there's one other aspect to this. You also have to set emissive white as a prop on the standard material. So if I get rid of that, everything should be black because there's just no light on anything. If we bring everything back in and refresh, things are mostly back to normal. All right. So that's actually everything related to loading the video. It's pretty easy. As long as you know about this trick where you can load in a video as a DOM element. But it still looks pretty boring, kind of lame. So why does this other one look kind of like weird and wobbly and like glowy, and there's like a glitch effect going on? All of that is coming from post-processing effects. Now, post-processing effects are a part of Three.js. So in Three.js, there's a concept called the EffectComposer. And the EffectComposer is a class that it just applies multiple different effects at the same time and blends them together properly. So if you look at the EffectComposer docs, you'll see all kinds of different examples here. So here's one called Unreal Bloom. That's really cool. So it makes some neat glowing effect on everything in the scene. There's a lot of them. So there's like this one, which makes everything look all pixelated. There's this one that makes these really cool God rays. Wow, that looks awesome. We should do a separate tutorial just on this one. And then here's the same glitch effect that we are using. But anyways, there's a whole bunch of these, and we can recreate this using React 3 Fiber. And Drei also provides a really nice helper for the effects composer, and it's a component called effects. And this is just like shorthand for using the effects composer. Yeah, so they just call it an abstraction around 3-zone effects composer. So to get started, we just need to import that first. And we will do that. And then we'll add it to the scene as well. Right. So now we have the effects composer, but with no effects. So it's really not doing too much. There are some defaults here that are kind of changing our lighting a little bit, but we now need to get all of our effects imported and applied. So this step is a little bit different than the other ones because we're going to be using effects directly from 3. So we're just going to get the bloom pass and the glitch pass first, because those are already included in 3. There's one other effect we're going to cover, but that is a custom shader that someone else wrote, and we're going to import it separately. Just as an example of how you can write your own effects using shaders with WebGL once you learn that someday. Or if you already know how, you can do it today. But let's start with some of the built-in ones. So bloom pass and glitch pass. So we're importing these, but these aren't like normal Three.js classes. They're kind of bonuses, which means that React 3 Fiber doesn't know they exist. And so you can't just start using them as a component like you can with a standard material or the video texture. You need to do one more step, which is to use the extend function, which is an export from React 3 Fiber. And you do that by importing extend from React 3 Fiber, and then at the top of your scene, call extend with an object. And inside that object, pass in all of the Three.js classes that you want to add to React 3 Fiber. So this will add bloom pass and glitch pass to React 3 Fiber, which if everything worked correctly means we should be able to go down here and use bloom pass. Notice that I'm typing this in lowercase. That's a convention that React 3 Fiber has. Whenever you extend a Three.js class, it will make it available in JSX as a lowercase component. So we also need to attach this. So we attach array, and then the value of that is passes. So this will make sure that it actually gets applied as an effect. And then while we're here, let's do the same thing with the glitch pass. Attach array, passes. All right. So now that we have these two effects on here, things are starting to look a little bit cooler. In the other scene, we also have a red little highlight going on here. That's just this point light. So we could take this lighting and replace our temporary lighting. So now we've just made the directional light a lot less intense, and don't actually need the position. And then the point light here is just a red light that's sitting to the side of the TV. All right. So this is good. There is one more thing that we have in the final version of the project, and that is this water pass. So the water pass is really interesting because it's causing the whole like scene to kind of deform and have a bit of a waviness to it. If I turn off the other two effects, it's very clear what it's doing. So I think that adds a little bit of neat otherworldliness to the scene. So let's add that too. And another reason I want to add this, besides that it looks cool, is that it demonstrates that you can write your own post-processing effects using shaders. This one is written by someone named Virgil Wang. I've seen it used on various other tutorials around the internet, but we are also going to use it. So let's take this whole file here, and understanding exactly how this works is somewhat beyond the scope of this tutorial. Maybe someday I will do a shader tutorial, but I'm not that great at them either. I've only written basic ones. So we'll just use this. So let's make a new file, call it waterpass.js. Get the whole contents of that shader in here. And then just like with the other shaders, we import it. So we'll call it water pass. Fix our import statement. And then just like before, we also need to extend that. Okay. So we just added like a totally custom shader to React 3 Fiber, and that's kind of a big deal. We can do a lot more with that in future tutorials. For now, let's just add our water pass to the scene. Refresh. And figure out why it's not working. Oh, let's attach it to the array, and then we'll also set this prop factor 1, which controls the strength of the effect. So now if I refresh, there we go. So now we're getting our wibbly wobbly effect. And if we turn that way up, things get even more crazy. So you can start to see the power of using post-processing effects. You can make some really neat effects with them. Most of them have some type of properties, like glitch pass has one that that makes it just go totally crazy. So let me find what the name of that is. Go wild. So okay, so there's a value that you can set on the glitch pass called go wild, I guess. Yeah, okay. So setting that prop on the glitch pass component makes the glitch just go like on overdrive nonstop. The bloom pass has, and like it's impossible to memorize all of these, but if you use them enough, eventually you'll figure out some cool settings that you can change. So just go look up like other tutorials about those shaders or find the documentations for them, and you can figure out how they can be tweaked. But that's it for our tutorial. We've accomplished everything we meant to accomplish. We talked about loading a video and then setting a video texture on a material so that the video will play on the geometry. And then we also created an effects composer and added a couple effects to it. And we made the cool TV scene. I hope you have fun with this. Hope you make some other cool stuff. If you do make anything cool, please post it in the comments. I'd love to see it. Have a great day. Bye.